Solving linear inequalities in one variable, objective 1, graphing inequalities on a real number line. When representing an inequality on a number line, we graph the inequality using a bracket, left bracket or right bracket, or solid circle if the endpoint and endpoint value is included in the solution set of the inequality, and a parenthesis, left paren or right paren, or an open circle if the endpoint value is not included. Number 2, graph the set of all real numbers x such that x is strictly greater than -2. So for a strict inequality, strictly greater than -2, we're going to use a left parenthesis to exclude that value, not include that endpoint, and shade the portion of the number line to represent all the points whose coordinate is greater than -2. Number 3, write the inequality in interval notation. So if we think about which infinity to use, the numbers that are less than -5 lie to the left, and to the left is -infinity. So the interval notation would be parenthesis or left paren -infinity, comma, -5, parenthesis. Now B has a weak inequality. It has the equals bar equals symbol. X is any real number greater than or equal to 10. So we'll use a left bracket at 10. The shaded interval is to the right. To the right is positive infinity. So the interval notation to represent this set of numbers, this inequality, is left bracket 10, comma, infinity. Objective 3, solving linear inequalities using the properties of inequality. Number 4, true or false. The addition property of equality states that the direction of the inequality symbol does not change regardless of the quantity that is added to each side of the inequality. That is true. So that means whether you add a positive number to both sides or add a negative number to both sides of the inequality, the inequality symbol does not change direction. Number 5, when multiplying both sides of an inequality by a negative number, we reverse the direction of the inequality symbol. That is true. For example, if we begin with a true statement like 1 is less than 2, which is a true statement, if we multiply both sides by, say, a -1, and 2 times -1, to keep the truth value of true, since the product 1 times -1 is -1, and 2 times -1 is -2, well, -1 is closer to 0 and is greater than -2, so to preserve the truth value of true, we have to flip the inequality symbol when multiplying by a negative number on both sides. Number 6, true or false, when multiplying both sides of an inequality by a positive number, we reverse the direction of the inequality. This is false. When multiplying both sides of an inequality by a positive number, we keep the inequality symbol in the same direction. Number 7, solve the inequality. Graph the solution set. Step 1, get the expression containing the variable on the left side or one side of the inequality. And this is done. Step 2, to isolate the variable term, in this example, we're going to subtract 10 from both sides. So -10 and 1 minus 10. So 10 minus 10 is 0, so we have 3x is strictly greater than negative 9. To isolate x, divide both sides by positive 3. So 3x divided by positive 3. And since we're dividing by a positive number, we keep the direction of the inequality symbol the same. So x is, as a solution, any real number greater than negative 3. In set builder notation, that means to use the curly braces. The solution set is a set of all real numbers x. Vertical bar means such that x is strictly greater than negative 3. In interval notation, since it's a strict inequality, it'll be left parenthesis, negative 3, comma, and to the right we'll have positive infinity. So the solution set will exclude negative 3 with a paren, and then shading to the right is the graph of the solution set. Number 8, when multiplying or dividing both sides of an inequality by a negative number, remember to reverse the inequality symbol's direction. Solve the following and state the solution set using interval notation. Part A, to isolate x, we need to divide by a negative 6. Thus, we have to reverse the inequality symbol. So the solution set is x is greater than positive 12. So the solution set, since we have a strict inequality, will be parenthesis 12 comma positive infinity. To solve for x in part B, we have a negative fraction. So we're going to use its reciprocal. And let's multiply both sides by the reciprocal of the coefficient. Let's put the negative with the 5. So we have negative 5 over positive 2 times negative 2/5. And since we're multiplying by a negative number, we have to reverse the inequality symbol and multiply the right side by negative 5 divided by 2 times positive 10. Oop, and we x in there. So when we group the product of reciprocals, we always get positive 1 because we're going to have positive 10 divided by positive 10, which is 1x, or just x. So x is less than or equal to, now we can multiply negative 5 times 10 or divide and cancel 2 divides 10 5 times. So then we have a product of negative 25. Solutions are all real numbers less than negative 25. So going to the left on the number line, the limit will be negative infinity, comma, negative 25. And it's a weak inequality symbol, so we're going to use a bracket to include negative 25 as a solution. Number 9, solve the inequality with fractions. Step 1, to rewrite the inequality as an equivalent inequality without fractions, we multiply both sides of the inequality by the least common multiple of the denominators. Multiply both sides by the LCD. Then remove or clear parentheses. So since the denominators are 6 and 2 divides 6, and 6 is a multiple of 2, we can multiply both sides by positive 6, and then divide 2 divides 6 on the right side 3 times. So then we have 4x minus 5 is less than or equal to 3 times 2x plus 3. Distribute the 3 on the right side. So 4x minus 5 is less than or equal to 6x plus 9. Combine any like terms if there are any on each side. Step 3. To get the variable terms on the one side, the left side, or the right side. In this case, we could subtract 6x from both sides of the inequality. So we get negative 2x. Subtract 5 is less than or equal to 9. To get the variable term isolated on the left side, we can add 5 to both sides. So we get negative 2x is less than or equal to 9 plus 5 is 14. To isolate x, divide both sides by negative 2. And since we're dividing by a negative, we have to reverse the inequality symbol. So negative 2x divided by negative 2 is greater than or equal to 14 divided by negative 2. So the solution set is x is greater than or equal to negative 7. Using set builder notation means use the curly braces. The solution set is a set of all real numbers x such that x is greater than or equal to negative 7. Close brace. And interval notation, since we have a weak inequality, we have to use a bracket to include a negative 7 in the solution set, comma, and to the right on the number line will be the limit of infinity. Number 10, write the appropriate inequality symbol to translate at least. So numbers that are at least will include the endpoint value with a weak inequality. This would be greater than or equal to. More than is just like is greater than in part D, so that's strictly more than, strictly greater than, so part D is the same answer. No more than means translation up to and including some value. So values that are less than or equal to will be not more than whatever the limiting value is. Fewer than is just like is less than in part H. So fewer than is less than. So again, H has the same answer. Part B, no less than. So that's just like not less than, so it has to be greater than or equal to. So numbers that are greater than or equal to will be not less than a given value. And part F, at most. So these will be values that will be less than or equal to. At most, some limiting value. So up to and including some value. Exercises, number 1, graph the set on the number line and express in interval notation. So we can mark 5 somewhere in the middle. N is a real number strictly greater than 5. So with a strict inequality, a left parenthesis, shading to the right, so the limit is positive infinity. And thus the interval notation is left paren 5, comma, infinity. Number 2 has a weak inequality. X is a real number less than or equal to 6. So we have to use a bracket, in this case a right bracket. And numbers that are less slide to the left. Limit negative infinity. Interval notation is left paren negative infinity, comma, positive 6, right bracket. Number 3, x is a real number greater than or equal to -2. So we have to use a left bracket and shading to the right, limit positive infinity. So interval notation is bracket -2, comma, infinity. Number 4 is a strict inequality. Y is strictly less than -3. So right parenthesis, right paren, shading to the left, limit -infinity. Interval notation is left paren -infinity, comma, -3, parenthesis. Number 5, use interval notation to express the inequality shown. So there is shading to the left of +3, and the endpoint at 3 is included with a solid circle. So we have parenthesis -infinity, comma, +3, bracket. Number 6 has shading to the right of -2. There's an open circle at -2, which translates to using a parenthesis, left paren -2, comma, positive infinity. Number 7, solve the inequality for x to find the solution set and express the solution set in set builder notation and interval notation. So to isolate x, we'll add 2 to both sides. 1 plus 2 is 3, so solutions are strictly less than 3. So we have a set of all real numbers x such that x is less than 3. Interval notation will be left parenthesis, -infinity, comma, +3, strict inequality, parenthesis. And let's put 3 here on the number line, left shading to the left, and a right paren, right parenthesis at +3. Number 8, solve for x, divide by +4 on both sides. So we have 4x divided by 4. Keep the inequality symbol in the same direction. Solution set is all real numbers x strictly greater than 3. So the solution set is the set of all real numbers x such that x is greater than +3. So on the number line we'll mark 3. And for a strict inequality, parenthesis, left paren at 3, shading to the right, limit infinity. So the interval notation will be parenthesis 3, comma, positive infinity. Number 9, now we have x terms on both sides. So let's subtract x from both sides vertically. That'll give us a positive leading coefficient, a positive coefficient on x. So 1x. And to move the constants to the right side, we'll add 2 to both sides. So +2 and +2. So x is greater than or equal to 5, represents the solution set. So we'll graph the set of numbers including 5 with a left bracket. Numbers greater than 5 lie to the right, limit infinity. So the solution set is, in set builder notation, the set of all real numbers x such that x is greater than or equal to 5. And in interval notation, it is bracket 5, comma, infinity. Number 10 needs to start off with a distributive property. So we have 2y minus 5. Let's also combine like terms. 2y plus 1y is 3y to save a little step. So 3y minus 5 is strictly less than 3y subtract 6. Now we have a pair of balancing terms on both sides, 3y and 3y. So when we subtract 3y from both sides, all the y terms are going to be eliminated. Just write it out horizontally. So we get the statement -5 is strictly less than -6. Well, -5 is closer to 0 and thus is not less than -6. This is a false statement. And therefore, there is no value for y that would ever make the statement true, since the y terms will always cancel out. You will always get a false statement for any real number y. So that means there's no solution. With no solution, there's no graphing on the number line. The solution set is the empty set, or you can use the null set symbol, or in interval notation, just a pair of parentheses containing nothing inside. Means no solution.